Have you ever gazed at the moon and wondered about the secrets it holds? From its role in shaping life on Earth to its stunning features visible even from millions of miles away, the moon is more than just a celestial companion. It's a world of wonder, with mysteries waiting to be unraveled. Are you ready to dive into 10 incredible things about the moon? Join us as we explore its fascinating facts, ancient impacts, and surprising characteristics. The moon was formed by a massive collision. One of the most fascinating aspects of the moon's origin is its dramatic creation story. Scientists believe the moon was formed around 4.5 billion years ago when a Mars-sized object named Theia collided with Earth. This cataclysmic event ejected a massive amount of debris into space, which eventually coalesced to form the moon. Evidence of this giant impact hypothesis lies in the moon's composition. Lunar rocks collected during the Apollo missions show a remarkable similarity to Earth's mantle, suggesting that both celestial bodies share a common origin. This finding has helped scientists piece together the violent history of our early solar system. The moon's formation played a pivotal role in Earth's evolution. The massive collision tilted Earth's axis, creating the seasons we experience today. Additionally, the moon's gravitational pull helped stabilize Earth's rotation, preventing chaotic wobbling that could have drastically altered our planet's climate. While we now have a clear idea of how the moon came to be, there are still ongoing studies aimed at understanding the finer details of its formation. Space missions and advanced simulations continue to shed light on the early years of Earth and the moon's shared history. The moon's birth story isn't just about its formation. It's a testament to the dynamic and often violent processes that shape the cosmos. Understanding this dramatic event helps us appreciate the interconnectedness of celestial bodies within our solar system. The moon influences life on Earth. The moon is more than a distant companion. It plays a critical role in shaping life on Earth. Its gravitational pull is the primary force behind ocean tides, creating the rhythmic rise and fall of water levels that have been vital to coastal ecosystems for billions of years. These tides, influenced by the moon's phases, help regulate marine life cycles. From coral spawning to the behavior of fish and other sea creatures, the moon's pull sets the pace for life in the ocean. Without the moon's steady influence, these ecosystems might not have developed as they have. The moon also impacts Earth's rotation. As the moon's gravity interacts with our planet, it slows Earth's spin by about 1.5 milliseconds per century. While this seems insignificant, it has a profound cumulative effect. Millions of years ago, a day on Earth was only about 18 hours long, but thanks to the moon, we now enjoy 24-hour days. The moon's presence in the night sky has also influenced human culture, from mythology and literature to calendars and rituals. Ancient civilizations carefully observed their phases to track time, plan agricultural activities, and guide navigation. The moon's impact on life extends far beyond tides. It's a silent but ever-present force that shapes our environment, culture, and daily rhythms. Without it, Earth as we know it would be an entirely different world. The moon has a far side, not a dark side. The far side of the moon has often been misnamed the dark side. But this is a common misconception. Both sides of the moon experience day and night cycles, just like Earth. The far side is simply the part of the moon that faces away from Earth due to tidal locking. Tidal locking means the moon rotates on its axis at the same rate that it orbits Earth, causing one side to always face us. This phenomenon is why we only see the familiar features of the near side, like the Sea of Tranquility and the Tycho crater, while the far side remains hidden from view. The far side of the moon was first glimpsed by humans in 1959, thanks to the Soviet Luna 3 spacecraft. This side has a rugged, heavily cratered surface, starkly different from the near side's smoother, darker plains. The lack of Maria or lunar seas on the far side is attributed to differences in crust thickness and volcanic activity during the moon's early history. Exploration of the far side continues to provide valuable insights. In 2019, China's Chang'e 4 mission became the first spacecraft to land on the far side, uncovering data about its unique geology and deep craters that could hold clues to the solar system's formation. The mystery of the moon's far side captures the human imagination, reminding us of the unseen wonders that await exploration in our cosmic backyard. The moon is shrinking. The moon is slowly shrinking as its interior cools. This cooling process causes the moon's crust to contract, resulting in the formation of cliffs called lunar scarps. These scarps can rise as high as 300 feet and stretch for miles across the lunar surface. NASA's Lunar Reconnaissance Orbiter has captured images of these scarps, revealing that they are relatively young in geological terms, just a few 100 million years old. Some scarps even show evidence of ongoing activity, indicating that the moon is still geologically dynamic. This contraction has caused occasional moonquakes. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes occur due to the moon's shrinking crust and the gravitational pull of Earth. While they are not as intense as earthquakes, moonquakes can last much longer, sometimes up to 10 minutes. The shrinking moon also provides clues about its thermal evolution. Scientists study the size and distribution of scarps to understand how the moon's interior has cooled over billions of years, offering insights into the thermal histories of other rocky worlds. The shrinking process is a reminder that even celestial bodies we consider static and unchanging are constantly evolving. The moon continues to surprise us with its ongoing activity and the secrets it holds beneath its surface. Moon dust is surprisingly dangerous. The lunar surface is covered in a fine layer of dust known as regolith. While it may look harmless, this dust is surprisingly dangerous. Lunar regolith is composed of tiny, sharp particles created by billions of years of meteoroid impacts, which have pulverized the moon's surface. During the Apollo missions, astronauts discovered firsthand how problematic moon dust could be. It clung to their suits and equipment, and even got into the lunar module, causing respiratory irritation and damaging seals on spacesuits and machinery. The jagged edges of lunar dust particles make them abrasive, posing a significant challenge for future lunar missions. Prolonged exposure to these particles could harm both humans and equipment, necessitating innovative solutions for dust mitigation. Despite its dangers, lunar regolith has potential scientific and practical applications. It could be used as a building material for future lunar habitats or as a source of oxygen through chemical processing. Researchers are exploring ways to harness this abundant resource while mitigating its risks. Moon dust serves as a reminder of the challenges and opportunities that await humanity as we prepare to return to the moon. The moon is slowly drifting away from Earth. The moon isn't as stationary as it might seem. It's actually moving farther away from Earth at a rate of about 1.5 inches per year. This slow drift is caused by the gravitational interactions between Earth and the moon, specifically the transfer of angular momentum due to ocean tides. Tidal forces create a slight bulge in Earth's oceans, which exerts a gravitational pull on the moon. This pull adds energy to the moon's orbit, causing it to spiral outward over time. Though the change is gradual, it has profound implications for Earth and its future. As the moon drifts away, its impact on Earth's tides diminishes. Over billions of years, this could lead to less dramatic tidal changes, which might significantly alter coastal ecosystems that rely on the moon's gravitational pull. Additionally, the moon's distance affects solar eclipses. A more distant moon will appear smaller in the sky, eventually making total solar eclipses a thing of the past. This phenomenon also tells scientists about the Earth-Moon system's history. By studying lunar rocks and Earth's geological layers, researchers have pieced together how the moon's gradual drift has influenced Earth's rotation and climate over millions of years. The moon's drift reminds us that even the most familiar celestial bodies are not static. They are part of a dynamic and ever-changing universe with ripple effects that extend across space and time. The moon has an atmosphere, but it's extremely thin. Contrary to popular belief, the moon does have an atmosphere, but it's so thin and fragile that it's called an exosphere. This exosphere is composed of rarefied gases, including helium, neon, and argon, which are present in trace amounts compared to Earth's dense atmosphere. The moon's exosphere is constantly being replenished by several processes. Solar wind particles, micrometeoroid impacts, and the slow release of gases from the lunar surface all contribute to this tenuous layer. Unlike Earth's atmosphere, the exosphere doesn't provide protection from radiation or support for breathable air. Because of its lack of a substantial atmosphere, the moon experiences extreme temperature swings. Daytime temperatures can soar to 260 degrees Fahrenheit, while nighttime temperatures plummet to -280 degrees Fahrenheit. Without an atmospheric buffer, there's nothing to distribute heat evenly or shield the surface from direct solar radiation. This thin exosphere still holds valuable scientific insights. For instance, studying the moon's exosphere can help scientists understand the behavior of gases on other airless celestial bodies, such as Mercury and certain moons of Jupiter and Saturn. The moon's delicate exosphere highlights the challenges of future human exploration and settlement, as well as the ingenuity required to adapt to its harsh environment. The moon experiences moonquakes. Just like Earth experiences earthquakes, the moon has its own seismic activity, known as moonquakes. These quakes were first detected during the Apollo missions when astronauts left seismometers on the lunar surface. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes have different origins. Moonquakes can be triggered by the gravitational pull of Earth, meteorite impacts, thermal expansion from sunlight, or the moon's internal cooling and contraction. Some of these quakes can last for an extended period up to 10 minutes because the moon lacks the water-rich rocks found on Earth that help dampen seismic vibrations. There are 4 types of moonquakes: deep, shallow, thermal, and those caused by meteor impacts. Shallow moonquakes in particular can be quite powerful, reaching magnitudes of up to 5.5 on the Richter scale, enough to cause structural damage if humans were living on the moon. Understanding moonquakes is essential for designing safe habitats for future lunar missions. Structures must be resilient enough to withstand these quakes and other environmental hazards. Moonquakes reveal that the moon is not as geologically dead as we once believed. It's a reminder that even a seemingly barren world can have dynamic internal processes that are crucial for scientists to study. The moon has water, but it's trapped in ice. The discovery of water on the moon has been one of the most groundbreaking revelations of the 21st century. In 2009, NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, mission confirmed the presence of water ice in permanently shadowed craters at the moon's poles. These craters, located in regions that never receive sunlight, act as cold traps where temperatures can drop below -400 degrees Fahrenheit. At these frigid conditions, water molecules become frozen and remain preserved for potentially billions of years. This water ice holds immense significance for future lunar exploration. It could be used as a resource for drinking water, oxygen production, and even rocket fuel through the process of electrolysis. The ability to harness lunar water would make long-term habitation and deep space exploration more feasible. Scientists are also studying the origin of this water. It could have been delivered by comets and asteroids, or formed through chemical reactions between solar wind particles and the moon's surface. Understanding its origin provides insights into the history of water in our solar system. The moon's icy reserves symbolize untapped potential for human exploration and survival, paving the way for a new era of space travel and scientific discovery. The moon might hold clues about Earth's early history. The moon is often referred to as a time capsule for Earth's early history. Because it lacks weather, tectonic activity, and a thick atmosphere, its surface has preserved ancient features and records that have been erased from Earth over billions of years. Lunar rocks and soil provide clues about the early solar system. By studying the moon's composition, scientists have learned about the bombardment of asteroids and comets that occurred during a period known as the Late Heavy Bombardment. This era shaped not only the moon but also Earth, potentially delivering water and organic compounds critical for life. The moon's surface also offers a record of solar activity. By examining isotopes in lunar rocks, researchers can reconstruct the history of the sun's radiation and its effects on the inner solar system. Additionally, the moon's relatively unchanged crust holds information about Earth's early crust and mantle. Comparing the two bodies helps scientists understand how the Earth-Moon system has evolved over time, including the dynamics of Earth's magnetic field and plate tectonics. The moon's preserved history acts as a window into our past, reminding us that studying our closest neighbor can uncover secrets about the origins of our planet and the conditions that made life possible. The moon is a celestial treasure trove of mysteries and wonders, each fact revealing a deeper connection between our planet and its natural satellite. From its drifting orbit to the water hidden within its craters, the moon is far more complex and fascinating than it first appears. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the universe's wonders with us.